Another exciting week on BSD Now. We're queuing up with LLVM and linking news, a look at NetBSD's scheduler. We got routers, desktops, build systems, and more. Stay tuned for your place to be, SD. BSD Now, episode 176, Linking Your World, recorded January 11th, 2017. Hey, I'm your host, Chris Moore.
And I'm Alan Jude.
Yeah, glad to have you with us this week. We got another exciting episode, lots of good stories to get to, and as the title kind of hinted at, we got some linking to talk about. So tell us what's happening there. I hear that LLD is becoming a thing, so where are we at?
Yeah, so Ed Mass has been working through the bug tracker at the LLVM.org on the progress of actually building FreeBSD and linking the code with LLD rather than the GNU LD. And one of the last bits that was blocking it was some old legacy BIOS boot code, actually the BTX client, or BTX loader, which is one of the bits that actually helps the machine boot.
Was it C or was it like some assembly in there or something?
It was some assembly, but mostly it assumed that the ELF object it was loading had two PT load segments, but when compiled with LLD, because it has an extra read-only data segment, that meant there were three. So it would just cowardly refuse to do the last one and quit. A little bit of change to the code, and now it loads all of the segments no matter how many there are. It just loops over all of them and does them. And will work either way this way. Will also mean it won't explode again in the future.
So when LLD 2.0 comes out and has 5 segments.
Well, this is LLD 4.0.
4.0, okay. Yeah. Yeah, go
ahead. Basically talks about that. It says, with that change applied, he can link the entirety of the FreeBSD AMD64 base system, userland, world, and kernel with LLD. Raphael's also done some initial experimentation using Poudriere to do a FreeBSD package build using LLD, the head version, that's the one that's not even released yet, and found that about 20,000 of the 26,000 ports build successfully.
That's really good numbers for a first run.
And he says he's now looking at getting some continuous integration Jenkins jobs or something set up to test this on an ongoing basis so that we always be grabbing the latest version of LLD and get alerted immediately if some change in LLD means that 1,000 ports stop building, which would obviously be very useful to the project. I actually have a live update on that from stuff happening today, down to 307 build failures and 805 skip ports, mostly caused by the build failures, in WebKit GTK2, LibreOffice, FPC, which I think is a Fortran compiler, and Emacs 2.5.
Oh, some of those are the big boys like LibreOffice and WebKit. Those break with everything. If you look at them wrong, they break.
Yes, but the fact that only blocks like 1,000 ports seems. Yeah, I would have thought WebKit and so on would end up blocking a little more than that. But I think importantly, WebKit not building blocks like XFCE from compiling, which is kind of a big deal.
Well, that blocks parts of Qt and blocks some. I don't think Firefox ships their own.
The WebKit that's failing is the GTK2 version, so maybe it doesn't affect Qt.
Oh. Okay, interesting. Yeah, that is different. Well, that's okay. Well, that's a really good number. It's a very manageable amount to go ahead and start going through and fixing those last stragglers.
Yeah, so once LLVM 4.0 is imported into Current and FreeBSD, we'll probably start shipping LLD beside LD so that it's easy to flip back and forth. And then maybe someday LLD will become the default.
Oh, that's fantastic. That's really cool.
And then
let's see. So you have a quote here. You want me to read that? Or?
No, just Ed was saying that while they work on it for getting the various ports to compile, it probably makes sense to collect all those local patches in a GitHub repo he set up under FreeBSD-ports. Sure. So I have the URL to that if you're interested in working on getting these ports building. And he says it looks like libtool is responsible for the majority of the failed ports, but judging by the fact that the number of failed ports dropped by 5,000 in the last, I don't know, it's been like 2 weeks since there were 6,000 ports that didn't build. I'm guessing they might have fixed that.
That's really slick. Well, I guess, do we have an ETA on when LLVM 4.0 might land at some point? I know we just switched to 3.9, it seems like not too long ago.
Yeah, I don't know what the timeline for that is. I don't know if 4.0 has actually been released yet, or if it's still in progress and then getting it imported and
to make it official.
Yeah. I'm guessing it depends on how much, or not so much how much change, but which things change, whether it takes a lot of work to import it or not. Like basically, it's like we grab the new version of Clang and then does everything still build? Yes? Okay, ship it. Otherwise, it's like, okay, now we have to figure out what's not working, then figure out if it's a bug in Clang or a bug in FreeBSD, and then get that fixed, and then, get the next point release of Clang that has the fix, and then
and so forth
and try to stay as close to upstream as possible so that we don't end up diverging and creating more work in the future.
Okay, really cool. Okay, well, for our next story here, we've talked a little bit about NetBSD's scheduler in the past. They've got some work they've been doing over there to update it. So tell us, what are the new flags, or what are the new things they've done to it? Is there any exciting stuff happening under the hood?
So we talked about the changes that they were working on, I guess it would be about a month or two ago now. Remember, if you're running under on Amazon EC2 instances, the last CPU never got a fair amount of the load because of a rounding error, basically. So you were not getting all the performance of the CPUs you had. And so a bunch of work went into fixing that. But this post is about work that went into documenting the tunables for this so that you can tweak things for your workload. With all these changes, there's now a set of tunables where you can control what happens with, how the scheduler decides when a thing should be moved from one core to a different core versus when it should just wait in the queue, right? It's like if there's a bunch of lines at the bank to talk to a teller or whatever, you decide you're going to get in this line, or say at the grocery store, right? There's all the lines for the checkout tills. You get in one line, but then you see the other line over there is moving much faster. If I go over to that line, will I end up in a better place, right? But, if I move, there's people behind me, right? So if I move, I've lost my place in that queue and now gone to the back of this other queue. Now, if it's moving faster, that's great. But if it doesn't, I've actually delayed myself more by moving. And so on. And also, if one new till opens and everybody's running for it, then I'm going to end up at the back of an even longer line. So there's a bunch of these different sysctls that you can control stuff with, like kern.sched cache HT time. This is cache hotness time is in which a lightweight pthread is kept on a particular CPU and not moved to another CPU. This reduces the overhead of flushing and reloading the caches. So the default is don't move a thread if its cache is less than 3 seconds old. So that trying to keep a thread in the same place because it's got cache there, and it means we don't have to try to deal with losing that cache. And then there's the balance _ period, the interval at which the CPU queues are checked for rebalancing. So how often do you want to see if I should move some things from, core 4 to core 2 because core 2 has a shorter line?
Sure. So these are all like milliseconds where you set the
all of these
the value
have to be given in hertz.
Okay.
Now, depending on your kernel configuration, the number of hertz there are in a second will be different. I know this causes interesting side effects in ZFS on FreeBSD because on Illumos and Solaris, the default hertz was 100. So some of the default values for the throttling for scrub and resilver on Illumos, when applied to FreeBSD, where hertz is 1,000 instead of 100, mean that we underload a resilver can finish 10 times faster on FreeBSD because it's actually degrading the performance of the workload more. Now, for a resilver, sometimes that's what you want, but it's just you have to.
Other times, not so much. Yeah,
you have to realize that the tunable is in hertz, not milliseconds. Even though by default, if your hertz is 1000, then it's the same as milliseconds. But if your hertz is something else, then it's completely different. So they direct you to the ms to hertz man page, which describes the relationship back and forth between milliseconds and hertz and how to adjust it and so on. Sure. So by tuning this value to a higher value, so longer amount of time, it won't check as often, so there will be less moving going on. So it means a process could stay on a busier CPU longer, but you get less moving. Whereas if you make it a shorter value, you'll be moving stuff more often, which may or may not help performance. And then there's the min cache, which is the minimum count of migratable threads for caching or stealing from another CPU. The default is 1, but can be increased to decrease the chance of thread migration between CPUs. So basically, we won't steal from another core unless it's got at least this many processes stacked up in its queue. Right? So 1 means that you know only if the line has more than just the person running and one person in the queue will we actually steal. Because in the amount of work it takes to steal that person over to this line, they could have gone through the existing CPU already, and this might actually slow them down. So increasing this value will reduce the chance that you're actually going to steal a process, and you'll only steal a thread from another CPU if its line is at least 2 or 3 people, or whatever you set the value to.
Sure.
Anyway, each of the different values is documented in detail in the man page, but also on this website to make it easy to read.
Wonder if anybody's done any kind of measurements under different loads and has like a good recommended value for all these now, or if they have a good set of defaults they ship with.
Interesting. It looks like a couple of these only apply if you use the new M2 scheduler, where the rest of them are based on the 4BSD scheduler.
Sure.
I don't know. I don't know much about the M2 scheduler. I know on FreeBSD we have the old 4BSD, and then we have the ULE one, which has been the default for quite a while now.
Okay. Well, good stuff. Well, thanks, Alan. Well, of course, you'll have to go play with that, NetBSD fans and users. Go give those a whirl. And, of course, if you get some kind of results or measurements, post it somewhere. That'd be neat to see what kind of settings produce the best outcome. Okay, so before we head to our next story, the first sponsor this week is going to be IX Systems, and the website for that is ixsystems.com/BSDNow. You'll want to go there, and there's a little form you fill out, name, email address, that kind of information. Once you fill that out, you'll be able to download a cool guide that'll give you kind of tips and tips of the trade, things you need to know when you're purchasing your next server for open source, things you need to ask your vendors, etc. And of course, you'll be able to get in touch with those great guys over at IX Systems. They're sales engineers who are pretty darn knowledgeable. The cool thing about talking to the IX folks is it's not like just buying something, say, at a retail store where the guy actually talking to you doesn't really know anything about the product that he's about to sell you. IX Systems, since we pretty much custom build a lot of the products that go out the door, they're able to change it up. So if you call up and say, okay, I want to do a mail server, I'm going to have this many users, or I'm going to do a big NFS server, or heck, I'm going to do a small FreeNAS Mini. I need something quiet that sits under my desk, or I need a whole bunch of RAM because we're going to do something in memory. Like, you just need to give them the details. What are you doing? That way they can help design the right system for you that's going to meet those minimum performance requirements you have. And of course,
but they can go even further than that. Like, they do custom work to, there's not enough room on the back of this, the IO plate on the back of this to actually fit the number of ports that I need. Or, I want to water cool a server, except for actually use an i7 processor that's unlocked and then overclock it to 5-point-something gigahertz. It's like, okay, let us build one of those for you.
And they can do that, and they have great partnerships with Intel, and of course can get the latest and greatest processors from them as well. So if you need a specific model of a specific chip, no big deal. Call them up, tell them why you need it or what you're doing, and they'll help find that right thing for you. Yeah. But of course, IX Systems makes that all pretty painless.
Yeah, that was a big advantage for me because I needed a very certain version of a processor, but it had to be a certain generation. I couldn't go older than Haswell because then it didn't have the performance of the QuickSync feature wasn't as good, or going back far enough didn't even support the type of video I wanted. But going newer didn't have open source drivers for it yet, or didn't even have available drivers for an open source operating system. And so, getting that, it was like exactly this one model of CPU. But they were able to do that. Where most other places, like, no, we switched to the new generation of chips. We don't have any old ones anymore.
Yeah. You don't have a choice, right?
Yeah.
No. IX Systems makes this a lot less painless, right? So definitely get in touch with them. No details too gory. Tell them exactly what you want to do and let them design the next system that'll meet your needs for 2017 and beyond. Okay, so our next story here. So we have FreeBSD network gateways on an edge router Lite. So I've seen a few things floating around the net about this. So tell us what people are doing with the edge router Lite, Alan. What's kind of the purpose of this?
So the Ubiquiti Edge Router Lite is a great device to run the edge on the edge of your home network. It becomes even better when you run FreeBSD on it. This guide documents how to set up such a gateway. There's an accompanying Git repo with all the scripts and everything you need to actually automate it. So the original work for this was from Colin Percival, who has written a great blog post on the subject on how he built his FreeBSD Edge Router Lite without needing a serial port, which has some advantages, especially if your computer is a laptop and doesn't have a serial port. In it, he provides and describes a shell script to build a bootable image of FreeBSD to run on the Edge Router Lite, and has that script available on his GitHub repo. What this user did is took that further and built a Vagrant-based workflow to automate the building of the drive image and an Ansible playbook to actually implement all the bits. So basically took the script that Colin Percival wrote and extended it and automated it with Vagrant and Ansible so that you could automate this, especially if you were, say, deploying these for other people and wanted to be able to update them on a regular basis.
Makes it too easy.
He says, once you've built the disk image, it's time to write it to a USB drive. There are two options. You can overwrite the original Edge Router Lite software on the original drive, or you can add a new drive. So he went for the second option and got a SanDrive UltraFit 32 gigabyte USB flash drive and did that. So he set that. He says actually that model of USB drive didn't work for some reason. Anyway, he says the tutorial then goes through and covers all the steps to actually set it up, including all the configuration files from rc.conf and setting up the IP configuration, doing the DHCP client towards your ISP, but also doing the DHCP server towards your LAN, and also doing it for V6, because this user has Comcast and actually gets native V6 from its ISPs and then distributes that to the machines on his network. It has the config for PF, setting up Unbound as a local DNS caching resolver, and all that stuff. He says, in the end, he says, I'm pretty happy with the Edge Router Lite and FreeBSD. He says, there's great community documentation on how to configure all the pieces of software that make FreeBSD-based home network gateways possible. I can tweak things as needed and upgrade whenever newer versions become available. My plan is to upgrade the base OS or when he wants to upgrade the base OS, he's going to get a third-party USB drive that works, write a newer FreeBSD image to it, and replace the drive in the Edge Router Lite enclosure. So actually swapping the physical drives as a way of doing the equivalent of boot environments. This way I can keep a bunch of drives in rotation. Upgrades to newer builds or revert to last known good versions is easy as swapping the USB drive. Although I pointed out that with something like a NanoBSD style, he could do something similar. Like if he just partitions his 32 gig drive into two 16 gig drives, or get a 64 gig drive and do two 32 gig partitions, and then writes his image to one of the older partition, and then just setting the boot flag to flip between the two, he could do it without having to physically change hardware, which can be a lot easier to do remotely. Yeah. And remotely is also where you are even more concerned about making sure that the router can boot if something does go wrong.
Yeah. If it fails partway through, it's like, I can flip back.
So it just automatically, if you just power cycle it, it'll go back and try the other one. And it says, configuration with Ansible means I don't have to manually do things again and again. As the configs change, they'll be tracked in his Git repo, so he has version control over it all. He says the Edge Router Lite is simply a great piece of network gear, and he's tempted at using those and other similar products instead of a mix of DDWRT and OpenWRT devices that he's using now. But he says that's for another blog post in the future.
Sure. Okay. Well, very good stuff. You have to check that out. I assume there's a lot of fans of Edge Router Lite out there. So I know people in the chat room have said so in the past. So good stuff. Okay, so our last story in the main news section here is we have a highly portable build system targeting modern Unix systems. So this is kind of a new/old project which has landed up on GitHub and has gotten some updating recently that we wanted to bring your attention to. But it's called BSDOwl, and it's a BSDOwl, OWL, by the way. It's a highly portable build system based around BSD's version of Make that supports a variety of popular and some not so popular languages. And some of the things they've targeted is things like C programs, of course, C libraries, static shared, compiled for several targets, shell scripts, interesting, Python scripts, OCaml programs, OCaml libraries, and then plugins, text documents prepared for several printing devices, metapost figures such as PDF, PS, SVG, PNG, things that are part of the text document or standalone documents. So that's kind of neat. So what about other features, you may ask? Well, it turns out BSDL actually has plenty of these to go around as well. But at the moment, it supports things such as the support of compilation profiles, and support of parallel mode at the directory level, support of separate trees for sources and objects, architecture-dependent compilation options, supports GNU's AutoConf, which is handy, and production of GPT-signed tarballs. Also, developer subshelled, which is empowered with specific project-specific scripts. And let's see, so there's some literate programming using NoWeb and preprocessing using M4. Mm-hmm. So that's actually a pretty strong list of features they're boasting here. So one of their claims to fame, though, is they've talked a little bit about multi-platform support. So I guess it's heavily tested against OS X, Debian Jessie, and FreeBSD greater than 9.0. They say future support for OpenBSD and NetBSD is planned, but that's, of course, going to happen once they update their respective BSD make binaries to more modern versions. So definitely need to check that out today if you're looking for a new build system that's a little more BSD friendly and give you something new to play with. Definitely check out BSDL. We'll have the links in the show notes, but it's up on GitHub for your perusal. Okay, heading over to the news roundup now. So we have a first thing here is actually something kind of neat, the find command. How often do you hear about new things getting added to the find command these days? But OpenBSD has done it. So it looks like, what did they add?
Added a new old
delete
thing.
Operation. A new old thing, right? Okay. New to them.
So Ted Unangst says
yep.
He's added the -delete option to find. He says this option is not POSIX, but not like that stopped find from accumulating dozens of other extensions. But it's been in FreeBSD and GNU for at least 20 years. It's also somewhat popular among sysadmins and blogs. And perhaps most importantly, it nicely solves one of the most troublesome caveats of the find command, which the man page actually covers twice because it's so common and so easy to screw up. So I think it makes it a good addition. He actually stole the code for doing it from FreeBSD.
Of course.
And it says, in passing, you'll find... so he said, passing, I'll also note that the man page example is very inefficient. In this case, find in the current directory all files named star.jpg or star.gif, and then exec rm on the file. This would be much faster if they used the plus operation.
Sure.
You can fix that too, but you'll need to add a lot of... but he says, but I'll add that a lot of the online advice uses a delete, and if that's not available, to use the exec rm thing. So it says, so the FreeBSD find utility will now have the delete option, starting with the snapshots of current, and then eventually in the next release, and so on. What's interesting is
nice.
The delete option is actually much more performant, because instead of having to fork out and start rm once for each different file name that you want to delete, it can just call the unlinked system call directly from inside find.
Sure.
So this
makes it quick.
Yeah, so when deleting many, many files, this is much faster. And it's also safer because you don't have the risk of mangled path names. So in particular, file names that have special characters in them or spaces in particular, if you call rm for, a file called, Chris space Ann space Alan, if the spaces aren't interpreted properly as being literal spaces rather than the separator at the rm command to delete multiple files, you will actually delete the files called Chris and the file called Alan, not the file called Chris and Alan.
Yes,
and also get an error because
behavior.
the file and was not found.
Yes,
this will confuse you greatly and erase the wrong thing. A malicious user could maybe set this up on purpose to make you delete something you didn't want to delete or shouldn't delete, and so on.
Sure.
So if you do encounter a system that doesn't have the -delete option, your best bet is probably to use the parameter of find called print0. So what that does is print out the file names rather than separating them with a space or a new line, because the space in particular, if a file name has a space in it, you can't tell the difference between a space and the separator, or even just a new line, because you never know. The print0 option terminates each file with the null byte by literally printing a 0 byte. And then if you pipe that into, say, xargs with the -0 option, which if you read the man page for xarg, it says this option is specifically designed to work with find print 0, that xargs will interpret the file names separated with a null byte, take care of the write escaping to pass them, and then, if you do xargs -0 rm, it'll do two things. First, it'll make sure the file's names don't get mangled, and secondly, it will batch them up. So it will run rm on as many files as your the maximum length of a command line allows, and then it'll start a second rm with a second batch, and so on. And you can tweak the options to actually have it run multiple RMs in parallel if you want, and also to control how many files it deletes per fork of RM.
So still not as performant as doing the unlink correctly, but still better than just piping everything and doing it a million times.
Depending on your setup, the xargs one could be faster if you make more of them run in parallel, because the find's going to unlink each file individually. Whereas the xarg one is going to start many RMs that are going to do those unlinks for you. So depending on how many files you're trying to delete, what the underlying device is, and so on, if it would actually be more performant to do, say, 8 RMs concurrently, there might be some advantage to using xargs, but how often are you deleting that many files and in that big of a hurry?
I was going to say, this is a very special use case. You got to be the kind of guy that has a gazillion files and you needed to delete some very large subset of those files.
But, especially with ZFS, when you're because when you delete a file, there's actually some writing going on where you have to, mark those blocks as being able to be freed once the snapshots get destroyed, and so on. Sometimes I found RM can be a little slow. And so running 8 of them at once maybe will solve that. Or maybe it won't. I don't know. But either way, it's a nice thing to see OpenBSD have the -delete command. I didn't know they didn't have it. But interesting conversation there, and that they've adjusted.
And hopefully you learned some new tricks, like with your xarg and find command usage. I wasn't aware of how you could parallelize those.
I think that parallelize
new. Today I learned.
Parallelize has been there for a while. What was added recently, which I'm pretty sure is in head because I helped get it committed, was an auto option, which will run as many RMs as your user is allowed to run at once. Which might not be what you want to do.
I wonder if you can run out of memory.
Well, I think there's one option that was added that automatically does the number of CPUs you have. So one for each CPU, which can be quite useful. Anyway, I forget exactly, but I know that I helped patch xargs to be smarter on FreeBSD, or to have more of the features that it has in other places.
Very nice. Okay, well, next up, so we have something new to kick off 2017. We have a new release of the Lumina desktop, version 1.2.0. So we have a link to their website here and blog and all that.
So do you know this guy?
Yeah, this Ken guy. We might have to have him on again at some point. I know he's working on a new window manager at the moment to replace Fluxbox, so we'll have like a completely native built-in window manager. But anyway, for this release in particular, some of the new features, well, first of all, there's some fixes to make it easier to port to other platforms. So they dropped a library and stuff and kind of made it a little more self-contained. But on the feature side, there's some new panel plugins. There's an audio player, which is just kind of a new plugin you can plop on your desktop and play music. Lets you play audio files directly through the desktop itself. So if you like having your media player embedded somewhere, you can do that. There's a JSON menu, which is a panel version of another thing we had as a menu plugin. It allows an external utility or script to be used to generate menu contents on demand. So you can basically put like a list of stuff on your menu if you need lists for some reason. New menu plugins, there's a lock desktop option, so you can right-click instantly and lock the desktop session, some more convenience functions like that. that. On the new utility side, though, they added a new archiver called Lumina Archiver. It's a pure Qt5 front end of the tar utility for managing and creating archives. It can also use DD to burn, for example, USB images to a USB device for booting, that kind of stuff.
Which is funny because that actually comes up as one of our later stories in the show. It's about using DD to burn an image file. But
no, we've been using that internally. Like our support people need it because we get tarballs all the time as debug files from like FreeNAS. And it was like, okay, in Lumina would be nice. Now I can just double click the file in Thunderbird or wherever it's attached, and boom, it opens up in an archiver, and I can browse and do all.
So is that actually using the tar command in the background, or is it using libarchive?
I actually don't know. I have to ask him. I should get him on here at some point. I don't know how he implemented that. I know it's. Maybe it is libarchive. I'll have to ask him. Yeah,
it probably makes sense to use libarchive, mostly since the tar command on BSD tar is mostly just a wrapper around libarchive anymore.
It is. So I would assume, or I would hope he's using libarchive, but if not, I'll have to bug him to do that. So yeah, I don't know the answer to that. Good question, Alan. I'll ask him. He's not here at the office today. Otherwise, I would go bug him here in a second, but we'll check with him later. Cool. Okay, so it sounds like some of the news about the release is already making the rounds to a few different sites, though. It looks like Phoronix and Softpedia have already picked it up as well. We have some links to that if you want to check it out. As a aside, if you're a TrueOS user running the latest updated packages, you're already running a pre-release version of 1.2.1. We roll with pretty much the latest and greatest all the time, so no worries there. And you can just update your system to grab even newer than 1.2.0 and get some of these new features as he adds them. So definitely check that out today. Okay, so time for our second sponsor this week, which we're going to be heading over to DigitalOcean next. And, of course, the website for that, digitalocean.com. No slash or anything at the end. Instead, after you make your account, especially if this is the first time you've made an account, you can't do it if you've already applied coupon codes. But if you're a brand new user, you go ahead and use the coupon code FreeBSDNow. And what that coupon code does, not only does it let them know that, hey, you heard about it here, but it also gives you a $10 credit, which is good for, heck, running 2 months of a VM, their lowest end VM, or even longer if you're paying for it by the hour, for example. So you can run a VM for a long time, especially if you have something you're not ready to put in production, you want to have some time to tinker with it. You're like me, where you start projects that are probably too ambitious and you don't have time to finish them, so you need to be able to, spin it down, not pay for it, and then come back to it again 2 weeks later when you have a little more free time. So very handy for that kind of thing. But of course, DigitalOcean doesn't stop there. Of course, they have FreeBSD support. That's kind of if you didn't gather that already, they do. And FreeBSD on ZFS as well. But if you want to load Open, Net, Dragonfly, you can do all that through their interfaces. And they do have some Linuxes hanging around if you really need to spin up a Linux. Not that me and Alan would ever encourage such a thing.
At least this way,
maybe for research.
At least this way, the Linux isn't at your house.
That's true. That's true. But anyway, so they, of course, allow you to do all that stuff. And they have a great API, which lets you do things programmatically. So you can spin down, create, and tweak your VMs all on the fly, script it if you need to, and locations all around the world. So they kind of have the complete package ready to go. Mm-hmm. If you haven't tried them today, we would encourage you. Me and Alan both use them for various things for our home and work and whatnot. So been very happy, and it just kind of keeps on trucking. As a matter of fact, my IRC is running through it right now.
Yep. But yeah, they have worldwide connectivity, lots of data centers to pick from, tier 1 bandwidth, the fact that you can actually use a gigabit or more out of their VMs, even the cheaper ones, and they come with lots of bandwidth. Even the $5 one comes with a terabyte per month of quota. The hypervisors have 40 gig Ethernet connections, so even though you have some neighbors that are also using some internet, there's still lots left for you. And you get the 4 nines of uptime.
Very nice. Very nice. So, of course, website again, digitalocean.com. And if you talk to anyone there, tell them you heard about it here on BSD Now. Okay, so the next article we have is DD is not just a disk writing tool. That's what I use it for. No, I use it for other things aside from disk writing. But what are they doing here exactly, Alan?
Yes. So they're basically just talking about, if you've ever used DD, you've probably used it to read or write disk images, right? And they actually show DDing an ISO to a USB stick.
Sure. That's probably most people's first experience with DD, would be my guess.
Usage of DD in this context is so pervasive that it's being hailed as the magic gatekeeper to raw devices. Want to read from a raw device? Use DD. Want to write to a raw device? Use DD. This belief can make simple tasks complicated. How do you combine DD with gzip? Well, the way I do it is with 2 copies of DD. DD input here, pipe to gzip, pipe to another DD. That's what I do. But and he says, how do you use PV, which is a Visual Progress Bar? if the source is
Which
raw
we
devices.
just put into FreeNAS, by the way. People wanted to use that to record like a ZFS send progress and stuff. Anyway, good stuff. Go
I
ahead.
use
Never
one
mind.
called bar, but it's the same thing. I imagine that one applies more on Linux, where you can't press Control T to see the progress. It actually comes up with another link we have at the end of this that we'll get to in a minute. But anyway, so I can understand when people want to use PV. Again, I do that with 2 copies of DD.
Sure.
Actually, in my replication tool, we use more copies of DD because of something we found in the FreeNAS source code for ZFS replication, where in order to unblock ZFS, they pipe ZFS send into DD, which is then piped into DD, so that if there's blocking, it happens in that middle DD, not in ZPool or ZFS send, so ZFS will keep sending or something. I forget exactly what it was, but yeah, I found that quite amusing. It's like just extra DDs in there, and it makes it magically makes it faster. I'm like, okay.
Another DD, it wouldn't hurt anything, right?
But he says, in fact, DD is not a disk writing tool. Neither D in DD stands for disk, drive, or device. It doesn't support any special low-level reading or writing, and it has no special dominion over any kind of device whatsoever. DD just reads and writes files. On Unix, the adage goes, everything is a file. This includes raw disks, and since raw disks are files and DD can copy files, DD can copy raw disks. But, you can actually do this even with the cp command. In this case, you can actually cp myfile.iso to /dev/da0 or whatever, and it would write the contents to that device. Or rip a CD by catting dev cd-rom to myfile.iso. Don't know if that works on BSD. Anyway, and it even shows how to gzip an image. So reading everything from a disk, gzipping it and writing it to a file without using any DD. Now, in that case, you're not reading in a specific block size where, there's only certain devices that really require you to read only a certain block size. But anyway. He says, however, this does not mean that DD is useless. The reason why people started using it in the first place is it does exactly what it's told, no more, no less. Whereas if you have an alias specified for CP that includes -a, it might try to create a new block device rather than a copy of the file data into the existing block device. If you're using gzip and you don't do the redirection, it might try to be helpful and skip the file because it's not a regular file. Or, neither of them will write out a reassuring status during or after the copy. Although CP with Control T on SIGINFO on FreeBSD will print out status as it's copying, but, nobody else has that.
Sure.
So it says DD, meanwhile, has one job, which is to copy data from one place to another place. It doesn't care about files, safeguards, or user convenience. It will not try to second guess your intent based on trailing slashes or types of files. There's, when this is no longer a convenience, like when combining it with other tools that already read and write files, one should not feel guilty for leaving DD out of this entirely. This is not to say that I think DD is overrated. On the contrary, it's one of our favorite Unix tools. So DD is the Swiss Army knife of the open, read, write, and seek system calls. It's unique in its ability to issue seeks and reads of specific lengths, which enables a whole world of shell scripts that have no business being shell scripts.
Sure.
Want to combine lseek and execve? Use DD. Want to open a file with the osync flag? Use DD. Want to read a group of 3-byte pixels from a ppm image file? Use DD.
Right.
That's one of the bigger uses I've had for DD is, I need to read from this file and I want to skip the first 512 bytes of it and then copy the rest. And I want to write it to this raw device, but not at the beginning. I want to write it
Somewhere
1
else.
megabyte into the file, because that's how you set up the boot code for ZFS.
So I guess I have used it mostly as a disk tool because I've used it for like the installer, like clearing out different parts of a disk or putting things in weird spots on the disk, etc.
And I'll talk about that in a second too, because the other thing DD is often used for is benchmarking. Because I just want to see how fast can I read.
Sure.
And so on. It says, So it says DD actually has two jobs: convert and copy. One of the features that doesn't really apply so much anymore that DD had was actually being able to convert data from the IBM mainframe format and so on back to ASCII and things like that. Like if you read the man page for DD, there's this whole subparameter called conv, as in convert, that has all these weird options, like making sure it's like, oh, my records are going to be this big, and if they're not, pad them with zeros and stuff. So it allowed you to convert all these things. It says, legend has it that the intended name, CC, for convert and copy, was taken by the C compiler. So the letters were just shifted one and gave us DD.
So it's CC++?
Kind of.
Right? That's good.
And this is like similar to the story of how our window manager ended up being called X. Because the original one, W, wasn't so good.
Yeah, W sucked, man. X is so much better.
So with the control T thing that sends sig info and makes DD or CP and basically every other command in BSD print out its status, somebody's made this handy website over here on GitHub called DD Countdown. In it, you basically type in the three numbers that come up when you press Control T on DD. So that's the total amount of data that you want to write. So like, you know how big the image you're trying to copy is. Then you hit Control T and DD and you type in how many bytes have been transferred in how many seconds. And it does the math and will actually draw a timer showing you how long is left. So it'll show you the speed and it'll actually build a progress bar. And assuming your speed doesn't change, it will accurately detect when you're done.
Oh, okay.
Allowing you to have a little progress bar in your browser, even though DD is running up there. You know, if you ever start DD and forget to pipe it through PV or bar or whatever progress bar, then there's your option. I thought that was cool.
Okay.
What I was looking forward to, there was some talk before, I think it was Ken Mary, I don't know if he ever finished, was CAM DD. A version of DD specifically that used the CAM layer to be able to talk to the raw disks without going through the regular syscall layer and that device abstraction. Actually using just the CAM subsystem to read directly from the disk and maybe even issue other commands to the disk.
So yeah, what kind of use case would be for that?
Well, that was, in particular, it was better benchmarking for disks and just the ability to do stuff with disks without having to go through the kernel. Basically, well, not without, you still go through the kernel, but using the CAM interface, which is designed to be faster and specifically for disks, rather than using the abstraction of we make the disk show up as a file and then try to use regular file accessing methods on it.
Okay. Very cool. Well, I think you learned more about DD today than you ever hoped. That's some good stuff, Alan. Thank you. Okay, so next up we have a Beehive set up for TCP testing. So I guess Hiram has been working on this over on FreeBSD land. So what's he doing exactly?
So he's working on TCP changes for FreeBSD, and he needs to test them. So in these two blog posts, he actually describes his setup of setting up 3 Beehive VMs and using DummyNet to simulate different network conditions. So he has 3 machines. He's got a client, a router, and a server. He says, so a few months back, I started looking at improving FreeBSD's TCP response to packet loss, looking around for traffic simulators which could do deterministic packet drops. So he wanted to, every so many packets, drop one, and then so we could try different tweaks to TCP to see if which one made it react better. He says, I had used DummyNet before, so we thought of using that, but the problem is it only provides a probabilistic drop. So it can drop a certain percentage of the packets, but it doesn't have a feature to guarantee that it will drop every, the 4th packet every time, rather than, you can drop 1 in every 4 packets, but you can never guarantee it'll always be the 4th packet.
Makes sense.
So he found a project that implemented some of that stuff from a university in Australia, but it was for FreeBSD 7 and couldn't easily be ported forward to FreeBSD 11.
Oh, yeah, that's quite a jump.
Yeah, that's often the problem with some of these projects at university is they write it, do their thing, and then graduate and move on.
And leave.
Yeah, and it didn't get committed, and so it didn't get maintained. So he wrote a quick little patch to do it, and he hopes to polish that up and actually get it committed so that it will be there next time he needs it. And, when we need it on some future version of FreeBSD. and so on. So he describes his network setup. So basically, each of the 3 VMs actually has 2 tap interfaces, except for the router, which actually has 3. But each machine has a 192.168 address, and that's for SSH and their connection to the internet and all the control stuff. So, allows them to go, that's actually bridged with his host's actual NIC and goes out to the internet and lets him install packages and it lets him SSH into the boxes. Then he has the separate network in the 10 network address space so that's where the actual testing happens. So there's no extraneous stuff going on there. So he can run TCP dump on it and actually there isn't his SSH traffic mixed in with it. This is very common setup for any lab type environment where you want to keep no packets except for the packets you want actually flowing across the test network. So yeah, he's actually got 6 tap devices and 3 bridges that he sets up. Right, so the client machine has tap 0 for SSH and tap 1 for the test data. The router has tap 2 for SSH, and then tap 3 that goes to the client, and tap 4 that goes to the server. And then the server has tap 5 for SSH and tap 6 that goes to the router. And it basically creates the 3 bridges. The first bridge is all the SSH connections and his real internet NIC. And then bridge 1 is the connection between the client and the router. And bridge 2 is the connections between the tap interfaces for the router and the server.
Sure.
So it walks through all that setup and shows basically how he sends data back and forth, how he creates the VMs, runs them, the configuration for everything, what CCTLs he has to do, and talks a bit about the dummy net stuff so he can actually make it drop, the 4th packet every 7 packets, basically, was the example he was doing. And trying to improve FreeBSD's TCP implementation to handle that type of packet loss better.
Interesting. Okay.
But it was interesting because this reminded me of a very similar setup. The reason he did this is so he can run TCP dump in all those different places and see what's happening. But I used a very similar setup to this when I was teaching TCP IP at a community college. We basically have the same thing set up, and the student would actually follow a packet as we had 2 routers in our setup. So the students sat in rows and all their computers were on a switch. Actually, I think it was a hub back then, but anyway. So they would send a ping to somebody in a different row. So it would go from their computer to the switch to their router, then from their router over a second NIC to a second router, the one for the other row, and then from that to the other person's machine. And they would have to follow the packet through the network and see that, the IP address stays the same every time, but each time it transits a cable, the MAC addresses in the packets are different. Right?
Okay.
And actually watching the TTL go down as it goes through the different hops and actually seeing what's happening with that.
I bet you had a fun class. That sounded interesting.
Yeah. It was, my example was always like envelopes inside envelopes. And then, you get the big envelope and you open it up, because it's Ethernet, and you open it up and it's like, oh, this is an IP packet for this person. So you put it in a new big envelope and address it to the next machine, and then it goes up the stack of the other side.
Did he say if he's come up with any fixes yet?
I think some of the fixes are there. But this blog post is just documenting his setup so that when he needs to do it again a year from now, he remembers what to do.
Yep. Okay. Well, hey, if you're working on any networking or whatnot, you might want to take a look at this and see how he had it set up here. This may help you as well.
Yeah. And it's also just a great lab environment for testing anything.
Yes, true. Okay, we're heading over to the Beastie Bits now. We got quite a few things to show you here, so we'll just get started with it. First up, we have Trent of IO Hive fame has a nice picture he tweeted of Plan 9/9 front installed working under FreeBSD Beehive with working networking. And then he shows a picture. I'm sure you can show it here, Alan, but a little confusing at first. Like, well, what is that? But yeah, it's Plan 9.
Yeah, he's actually running IP/ping. Send 4 pings to the Google public DNS server, and you can see the response is 36,000 microseconds or 36 milliseconds, which is a perfectly reasonable ping. But at first, it's like, why is there 5 digits in the ping? Something's not working? And it's like, no, that's microseconds.
Yeah, something's not amiss here. Do not adjust your set. It's okay. But that is really cool. If somebody wants to try Plan 9 and play with it, you have another place to do that. Beehive for the win again.
Yep.
Okay, so next up we have Getting Your Name in the Relay D book. Michael W. Lucas has some new stuff here. So it looks like he said there's a long tradition amongst...
Yeah, there's two different things going on. There's two different things going on here. The first one is the contest. So you go ahead and describe that.
Yep. No, you go ahead. You got it.
Okay. So it's a tradition that happens in fiction books where people can basically bid to donate money to a charity, and whoever bids the most gets their name used as one of the characters in the book. So on Michael Lucas's new Relay D book, which is actually nonfiction, he's doing something similar. So in the comment thread of this particular blog post, people can bid on having their name put in as the character in the book.
Sure.
And there's a bidding war going on here to get the rights to that. And then separately, once this, the donations for this will go to the OpenBSD Foundation, because this book is about OpenBSD's Relay D and so on. Once this is done, the regular donate to get your name in the back of the book or ebook will open up as well. So even if you don't win the auction, you can still get your name in the book.
Interesting. Okay, yeah, this looks really cool. Maybe by advertising a little bit here, we can push that bidding war up a little bit higher. Yes. But again, it's for a good cause. So if you'd like
for
to
the
see your name,
BSD Foundation.
And I'm reading through here, he has a very humorous list of all the exceptions, and like depending on what your name might be.
Yes. He will not write you into the book with a name of Henning Sucks.
Yes. But and he said, no, it cannot be my company name, so he's not going to advertise your firm and stuff like that. But anyway, definitely some good stuff. Okay, so next up we have Ted Ewing's 2016 computer reviews, where he gives us a rundown of his thoughts on computers over this last year. So let's go ahead and start here. He starts off with the X1 Carbon, says it was purchased January 2015. He said 2 years later, love it as much as ever. He said, I liked the T430s before it, but it was always a little too heavy to carry. But he said his X1 is an easy bag and go-to machine. He said, despite quite a few cycles, the battery's still up about 96% as original and generally lasts me longer than needed. That's the one I use too.
Yeah, I have a T530 and I still carry it around. And Ted's
those are solid.
Better built than I am, so I don't know what he's complaining about.
Well, and then you have those extra battery packs.
Yes, but I think one of his later conclusions is part of the reason why I have the T530 instead of something smaller. But
then he mentions a ZenBook UX305, which was purchased October 2015. He said it's a portable Windows 10 machine, but he said it's nice to have around. He said it's a little bit of a disappointment switching from the X1 to this machine, but it's still okay. Then he says an HP Chromebook 13. He said purchased July 2016. For the first few months, the machines was kind of a curiosity. He said I'd play with it, but didn't really use it. Recently, though, I've been using it a lot more. It's an excellent web browsing machine to the extent that I browse with it almost exclusively. If I want to get something done, though, I use the X1 and don't browse the web, which is really productive. When it's web time, he switches to the Chromebook. So that's interesting. That's a good use case there. And then he talks about a little bit about some other computers, which are not mobile, but an Edge Router Lite he purchased, iPhone 6 Plus, Kindle Paperwhite, and so forth. So that's an interesting list here. He's got quite a few systems mentioned here. Oh, and he even made his own hand-rolled gaming machine, too, with a GTX 970 in it. Or 980, excuse me.
But yeah, I think the big one is his final thoughts at the end. He says his future wants, he says, my default resting state is one of computer envy, so he always wants a better computer.
Sure.
He says, but most new machines aren't much faster. There's only, you can only get so thin and so light before you stop having useful ports and so on. That said, there's no way I'm ever using a laptop that weighs more than 3 pounds ever again. And his minimum resolution is now 1440p rather than 1080p. Because while 1080p was good a couple of years ago, like when I bought my T530, I paid like $400 extra to get 1080p instead of like
720 or something slightly less than 1080. They had some weird aspect ratios back then too.
Yeah. But he says now it's visibly subpar. And actually, at one point, he was talking about, for his gaming rig, having a 5K monitor.
Holy moly. I can't get into 4K gaming. I'm sorry, guys. It's just overkill at this point for me. I sit too close to the monitor. But anyway, craziness.
Well, I have ridiculously thick glasses.
Mine, unfortunately, are getting that way, too.
So, I like my 1080p on a 27-inch monitor. I don't want anything to be any smaller. Although, I know George Neville Neal's like, I just get stronger glasses and make the font really small and I can fit more on the screen that way. I'm like, sure.
That's what I've been doing. That's been my method going forward.
Anyway, a nice rundown, when you're trying to decide what hardware to buy, getting other people's feedback on how they found their Edge router Lite or their Braswell NUC or, what they've
and other
used
tech savvy developers too.
Exactly.
They're a little more, they will notice things that maybe your average consumer wouldn't. So I trust those opinions. Okay, so next up we have Brian Cantrell was on the Developer on Fire podcast, and we know what a hit Brian Cantrell is when we have him on the episode here, so we wanted to highlight that. So if you're looking for some more Cantrell goodness, go check it out. Episode 198, Brian Cantrell, Persistence and Action is the episode title.
Yes, even getting Brian Cantrell's tips on parenting.
Oh, okay. That sounds good. Let's see. Next up, 2016 in review, a IPFW's impact on forward performance over time on an 8-core Atom.
Yes.
And it looks like we have a nice chart here.
Yeah, so it shows the different FreeBSD revision numbers where he did the benchmarking over time, because he does these benchmarks every couple of weeks or something like that. Yeah, every 2 weeks or 3 weeks is all you would need to fill out this chart here. And it shows, you can see the green line is just raw forwarding performance. And then the blue and red lines are IPFW and PF and how those impact. And you can actually see a little bit of arrays going back and forth between which one's faster. This is an 8-core Atom, so it's not a very powerful machine. Well, it's not too unpowerful either.
It's not a slouch either.
Yeah,
it's an 8-core.
But it's we're not talking about a high-end E5 1650 with like 3.5 gigahertz cores or something like that. So the fact that it can saturate, we can see the changes, the forwarding performance when MJG did his trivial backoff and locking primitives. We see all of a sudden we went from 600,000 packets a second to like 1.3 million packets a second of forwarding performance. And then with AE's rework of try-forwarding to use the new FIB4 KBI for accessing the routing table, all of a sudden we went from 1.3 million packets a second to 3.1 million packets per second. Nice. So at your regular mix of internet-sized packets, that took forwarding performance on this CPU from, 3 point something gigabits per second to over 9 gigabits per second, which is a big difference.
Yeah, that's pretty cool. Okay, let's see. Our last one we have here is Johan Slunberg, who's been working on some Wayland stuff on FreeBSD, posts something on Twitter of Wayland Weston with X and EGL clients running on FreeBSD in VirtualBox with a new SCFB backend. He said more is coming soon. That's exciting to see. Yeah,
somewhat accelerated graphics in a VirtualBox, which by itself is a thing.
So the SCFB is not really accelerated.
Well, I guess not accelerated,
But the fact that you can run it in place of like having full acceleration is huge, because that means Wayland can run on things that aren't accelerated now. Like maybe Wayland could run on systems where we don't have a driver for it yet, which has always been a concern, right? Because Wayland depends on GL and these other primitives, DRM working properly. And to have it working without that with SCFB, pretty darn cool. And seeing GL executors run too is pretty slick.
With EGL and X and Wayland and Weston all running on FreeBSD, we're definitely against it. So I was, that'll be really nice to see. And also, congrats with much interest. Congrats on the ports commit bit that he got this week.
Yes, that is true. Okay, well, thank you, Johan. So now we need to go to our last sponsor this week, which we're going to be heading over to Tarsnap. Website for that, of course, tarsnap.com/BSDNow. That's where you'll want to go and get signed up pretty much right away. Don't wait. If you need to do backups, you need to start doing them sooner rather than later, because you don't know when the next disaster is going to hit. I mean, we can try and predict, and we have average, mean times between failures on drives and whatnot. But, there's always that weird case where it just dies on you out of the blue.
Yeah.
And it's never at a convenient time, unfortunately.
Double hard drive failure happen on a machine today. It's like, glad I was using RAID Z2 instead of Z1. Otherwise, I'd be really needing some backups right now.
Yeah, yeah. So the cool thing about Tarsnap is that it really is for the truly paranoid, right? So you can go to the website. The source code's all fully available. You can compile it from source yourself, so you can even trust the binaries you get. In addition, you can audit the source code, make sure it does what it claims. And what it claims it to do is it gives you a tar-like interface to backing up to the cloud, Amazon in this case, but everything's encrypted before it leaves your box. So if you're going to send a bit, it's already been encrypted with your private key, which you don't ever have to share. It never goes out over the wire. You can print it out and keep a backup copy of it. It's really nice, which that means if you ever need to delete stuff out of the cloud, which is next to impossible to do, a lot of people have tried, but you just don't know where all your bits have gone, right?
You don't know where they backed it up to.
Yeah, what cold storage is it running on? Did they actually destroy those drives? I mean, who knows? People can find stuff. So anyway, Tarsnap allows you to just delete your key, right? And then that encrypted data is pretty much rendered useless on the remote end and, so forth and so on. That's as good as you can get to just deleting it entirely. So anyway, check out Tarsnap today. They have clients for just about everything under the sun. So even Windows, Mac, Linux, for the different BSDs, obviously. And then you can roll your own if you'd like to do it that way.
There's even an experimental Debian package now.
Oh, nice. Okay.
He's been working on that lately.
Yeah, they have all kinds of good stuff. So go check out Tarsnap. Put a few bucks in. You'll be surprised. It just kind of sips your pennies. It's really cheap.
Yep.
But especially if you're doing data that doesn't change a lot, it only backs up the bits that have actually changed. So it does all the deduplication before it sends anything out.
It's not just block based. It's really smart deduplication.
Yep. That's right. They do it right. And that's why so many people swear by it and won't go back to anything else. So check it out today. tarsnap.com/BSDNow. Okay, time for questions. So first up is Eddie. He says, "Hi, Chris and Alan. In the last show, somebody wrote in because he experienced that after he deleted a partition, he recreated a new one on top, and then the data, of course, was still there."
Now, I think in this case, the user was actually happy that happened.
Yeah, they wanted that to happen. But sometimes that's not what you want, and that's very annoying. It's like, oh, where did this come from? He said he also experienced this sometimes, although he says now that we have SSDs, he has a simple and effective workaround. He said he just trims the whole partition of the disk. He said there's a bunch of different tools for this, like FS trim, block discard, HD parm, etc. He said trimming might take some seconds on a big disk or even some more minutes. He said if it takes too long for you, you can, of course, trim only the first and last dozens of blocks on the device.
Sure, although you can just write zeros over them with DD as well.
Yeah, you could use DD as well. But he says, but be warned before you do it, make sure you don't really need the data on the disk. Trimming erases the disk's internal logical to physical block tables, of course. So
yes, although depending on the drive, trim doesn't necessarily guarantee it's getting rid of the data.
True.
Yeah, if it just deletes that and then deletes the logical to physical mapping from its block table, the data might still be on the flash somewhere, which may or may not matter.
Securely, you're actually writing it over with zeros.
Some drives will guarantee that when you try to read from a block outside of the mapping or when it gets added back to the mapping, it will always return zeros rather than the data that was actually there and just not overwritten yet, where some don't. Mm-hmm. Or some will actually, depending on the firmware and whether it even keeps track of it or not, you can get different results from different SSDs. Which can be interesting as well. But yes, to this end, I was actually looking at making a gpart clear command or something that would just overwrite the first and last 1 megabyte of a disk or partition or whatever to make sure that you could nuke those things without having to wait to overwrite the entire hard drive.
Yeah, I would find that useful to have. Add that to gpart.
Yeah,
that would be good.
That's maybe one of the things I hope to do for the FreeBSD Storage Summit that's coming up in California.
Yeah. So next up, we have Matt F., who writes in, who wants us to convince him to use BSD. He says, "Hi, Alan and Chris. I'm trying to figure out if I should use BSD systems more than GNU Linux systems. Looking at ZFS on Linux, that diminishes the use of FreeBSD just for the file system. He said PF is great, but it isn't really an edge when software interoperability still occurs between the two operating systems. He said, I'm considering this from the idea of CentOS with ZFS on root versus FreeBSD for the server, and either Gentoo or Arch with ZFS on root versus FreeBSD or TrueOS for the desktop. He said, a side note, jail seemed like a potential tipping point for the server, but it's just not something I use every day. He said, I enjoy using both FreeBSD and several Linux distros. I'm trying to see if any of the BSDs are more of an occasional use case for me or something I'm missing big. What would you two recommend?" Well, you write to us like we're going to recommend something different.
Yeah. On your server, you should be using jails every day because they're awesome.
Yes.
Even if just like there's a couple of different aspects for it. There's the security one, but even if you just discount that one, but don't, because it's important. The containerization is just so useful. Like
Sure.
this week, I had a server which has a 10-disk ZFS pool, and most of the data had been moved off of it because we were planning to give it bigger disks. And rather than do that in place and resilver and over and over and over again, we're just going to destroy the pool and make a whole new pool out of 10 new bigger disks. But it still had a couple of services on it that were good, but they were in jails. So like one of them was the TeamSpeak server that I use for some of my friends for gaming. And that runs in a jail on FreeBSD. And I now needed that to not be on that server because that server was about to have all of its hard drives pulled out. And so I snapshot the jail and replicate it to a different machine. Then I snapshot the jail again and do an incremental replication to get caught up. So now there's only a couple of minutes of data that's newer on the old machine. So then I stop the jail, snapshot it again, replicate that. Only takes a couple seconds because there's only a couple minutes worth of writes. Transfer the config files over, start up the jail on the other machine, and then delete the jail from the source machine. And now, with only 40 seconds of downtime, I just moved the TeamSpeak servers from this server to that server. And now this server has no services left on it, and I can power it off and rip all the hard drives out.
Retired. Yeah.
That
Jails
just
makes that awesome.
Yeah. They're all set up so the IP address for the service is part of the jail config. It gets added to the network interface automatically when the jail starts and removed when the jail stops. So the IP moved seamlessly without me having to think about it. It was all just done. It was great. I love it. FreeBSD has much more mature support for ZFS on root. I don't even know how you do that in CentOS. Honestly, I think maybe they're getting there, but last time I looked, it wasn't even possible on CentOS.
Is boot environments a thing there? Like, have they ported over?
I don't think they have any concept like boot environments yet, which basically on FreeBSD allow you to boot any one of your snapshots or clones of your snapshots so that you can snapshot, do an upgrade. Oh, it didn't work. Boot back to how it was before. And files you changed in your home directory didn't get undone. Only the operating system changes did. And that's one of the other big things is FreeBSD separates the operating system from the packages and from the rest of the data. And that can mean that even if you screw up all your packages, the operating system still works.
Well, and aside from some of the feature buzzwords, sometimes people just get on it and go, I really like the layout of things, right? It feels cleaner. Feels better designed and implemented, where certain things live, where config files are, how package works, how the etc directory.
So I've got
you start seeing all these little differences that add up.
So
right?
on your CentOS server, try to configure link aggregation. Set up LACP or something to bond two network cards together in CentOS.
Right.
And then do it on FreeBSD. And then you will use FreeBSD forever.
Right.
It's like if config leg0 create this port, that port, this type, done. CentOS, edit 8 different files after you've murdered network manager D with a brick multiple times, and it keeps coming back to life, and it's like a zombie vampire.
Yeah. Well, hopefully those will be enough reasons for you at least to try it. I think it's one of those things you got to actually give it an honest try, though. After you've done that, then you'll decide whether it really fits what you want. But we're pretty convinced that you'll just like it and be like, I don't know how I would go back.
If you give it a good try and use it for things that it's good at, it definitely grows on you.
Yep. Okay, well, next up we have Sean. He says, hiya, fine folks at BSD Now. I'm a bit curious if there's any ZFS horror stories that can be shared on the show. He said, I've never been bit by ZFS bugs or improper pool configurations causing data loss, but I'd still like to hear people's stories from the trenches and how they deal with them. So my personal stuff I've heard from people more on the FreeNAS side is when they incorrectly configure the pool and they attach a device and stripe it when they meant to mirror it or something like that.
Yeah, like
right?
in most cases I can think of, I've heard of an improper pool configuration itself doesn't cause data loss, but it can cause you to be in a situation where if any one disk dies, then you have data loss.
Yeah. And it's just the undoing the bad configuration choices that were made is difficult.
Yeah, and I definitely can think of some people who have had to move all the data off and recreate their pool to get out from weird situations and so on. But
Yeah.
I can't think of, off the top of my head, any ZFS bug that's actually eaten anybody's data. Almost all of... I can't think of any case where ZFS data loss was caused by ZFS and not by the user shooting their own foot off.
Sure. Doing something improperly or
and
total catastrophic hardware failure.
The worst part is the ZFS purposely tries to prevent you from doing those configurations that are invalid, like adding something as a stripe. It says, no, you can't do that. Admittedly, the error message could explain why a little better so that people don't just put -F and force it to do it anyway.
Yeah, that's what I want. Do it. Yeah.
It's like, invalid VDEV specification. It's like, what? Use -F to do it anyway. It's like, well, if the error message better explained why that's invalid, maybe people wouldn't just use -F. So maybe there could be some documentation and some user interface fixes for it. But, ZFS painstakingly goes through the process of trying not to lose your data, and you really have to, bash it over the head repeatedly if you want it to lose your data.
You got to do some weird things. I mean, back in the early days, like when it was first ported over, there was, the weird edge cases or whatever. But for the most part, I mean, there's a lot of big companies using it in enterprise storage now. And a lot of those things have been sorted out a while back.
I've never really run into any bugs. I've seen lots of people run into interesting things. None of them ever resulted in data loss, though. Like I had somebody the other day in the chat room who was replacing some older disks with some newer disks, but the newer disks were used. So he moved the drives to a new server. In the old server, he replaced one of the drives with a newer drive, but that was still used with zpool replace. Then he moved all those disks to a new server, but in the process replaced one more of the disks, relying on the fact that you have the redundancy and just be able to zpool replace and continue. But when he tried to import the pool, when he booted from the pool shows up as faulted and only showed one of his disks as being available. Turns out what had happened is the used disks didn't have their old partitions and stuff deleted. So they had an MBR partition table with a big Linux data partition on it. So Geom locked exclusive access to the raw device because there were partitions on it, and it wanted you to access the partitions instead. But ZFS was trying to use the raw disk because that's what the ZFS label said to do. So his solution was actually gpart destroy the partition table, and then suddenly ZFS could see the disk just fine.
Right. It's like, okay.
So
interesting.
That's actually partly...
That's
a PJD bug. When he ported ZFS over, in Illumos, when you give a whole disk to ZFS, it actually puts a GPT partition table on it and writes one big ZFS partition. And sets the flag whole disk equals 1.
Sure.
But in FreeBSD, whole disk means literally the whole disk with no partition table.
Just the raw blocks.
But I don't know outside of BSD if there's ever really been you remember old dangerously dedicated mode where you didn't have an MBR, you just put a BSD partition slice label right on the disk. It basically does that. And so it means it didn't overwrite the MBR. Whereas on Illumos, I think it would have. And so I'm looking at maybe fixing that to make it more sane, because a number of problems crop up when you use just the raw disk like that. And while I understand people wanting to do it, it'd be better if it worked better.
Okay.
But so in this case, it was just the Geom is actually blocking it. So what's interesting is I thought the problem he was having was zpool import was saying, hey, that pool is missing too many devices, not importing. But when I looked at zpool status more closely, I noticed the pool was imported, but with not enough disks to be able to work. And I was like, how the hell does that happen? Well, the bootloader imported the pool because it could access enough disks.
Sure.
But once the kernel started and tried to take over, Geom locked access to one of the disks because it had partitions on it. And it was I don't want you writing to the raw disk where outside of the partitions, because you'll just clobber something.
Yeah, that would have been a pain to debug and figure out what's going on there.
Luckily, I figured it out rather quickly. Because at first I suspected that he didn't switch the disk the way he thought he did, and he put the Linux data disks in the box, and there was no ZFS on them, and so the disk that actually had his data was somewhere else. But then we figured out it was just he didn't erase the old partition table before he stuck it in the ZFS pool, and he was using raw disks instead of partitions. So, yeah.
Sure. Well, I'd be curious to know
horror stories. I think the only one we've ever heard from is actually an older Josh Petzel interview.
Yeah,
he had a couple.
He is the one that I was thinking of, where he had some really old war stories from back in the early days in the trenches, where people got in really sideways states.
Where running a V28 pool on V5000 had stomped the space map, but that didn't result in data loss. It just meant the pool could only be mounted read-only. Because when the space map was trashed, you couldn't tell where it was safe to write, so ZFS refused to write. But you could import it read-only, and then the problem in this case was the customer had like a huge amount of data, like hundreds of terabytes or something. And so I think the fix was Josh actually loaded up a giant disk array in his truck, drove to the client, and replicated all the data off the array to this temporary box, rebuilt the array, and moved all their data back for them.
Wow. Well, I think there was also some old horror stories, like when deduplication was first coming onto the scene, right, where people would screw up and end up
not being able to import because they don't have enough RAM.
Yeah. But if any of our listeners, if you have an alternate horror story, something we're not aware of, I'd be curious. Send it in. Yeah, we don't hear about those that often. So.
Almost always, data loss in ZFS is the operator's fault.
Yeah, that's hard to do.
No, we try to improve the safeguards to stop people from shooting themselves in the foot, but it's the Unix philosophy, right? We don't stop you from doing something stupid because that also stops you doing something clever. Like I did one of these the other day. I had a machine that I rented and had 6 hard drives, and the first one had FreeBSD installed UFS. And I wanted ZFS, and the other 5 hard drives were blank, right? So what I did was, after booting, created a new Z pool that consisted of a RAID Z1 of the 5 disks and a G0 device, which is a device that shows up as being an exabyte. If you write to it, it just gets thrown away to dev null. And if you read from it, all it ever does is return zeros.
Okay.
So I used that as the placeholder for the 6th device because you can't add devices to a RAID Z after you create the pool. So I created the pool with my 5 real disks and 1 placeholder, then immediately offline the placeholder, rsynced all the files from the UFS to the ZFS, then did it again because files change in the meantime, then dropped a single user mode to stop files changing, did it one more time, then rebooted, told the BIOS to boot off the second disk. So booted ZFS, and then I just deleted the partition table off the first disk, and Zpool replaced it for the fake placeholder disk, resilvered. It was only like, it took literally 1 second to resilver because there was like 200 megabytes because it was a base install of FreeBSD, it was like 250 megabytes compressed. And we had to put like 1/5 of that onto this disk. And so boop, it was done. These were all SSDs, by the way, so it was really fast. And then I reboot one more time, and look, I now have an all ZFS system. But ZFS normally tried to stop me from creating an array of 5 400 gig drives and one exabyte drive.
Sure.
It's like, all your drives are not the same size. Are you sure you want to do that? That can be important because you might have accidentally added a disk you didn't want to overwrite.
Yeah. That was not one of the new set I bought or something, right?
It's like, oops, I almost added the USB stick to the pool instead of the write device, and so on.
We've seen that happen too in the field. Well, I thought DA0 was this, and no.
Yeah, you always want to use your cam control dev list to map what's what. But yeah, there are lots of safeguards in ZFS, but it's important that ZFS maintains the ability to allow you to go around the safeguard with using capital F or small f for capital F.
Sure.
But people need to be careful not to do that unless they're absolutely sure they want to do that. ZFS
Straight
tried to,
warning.
like, almost every time. It's like ZFS tried to stop you, and you ignored it, and so it's your fault. But
Well, it's kind of like DD.
Yes.
You know, it's the Swiss Army knife. There's a lot of things you can do. You
what
probably
did I
have
do?
a lot of things you
I
shouldn't
DD'd
do.
the wrong thing. Oh, actually, it was Gpart at EuroBSDCon in Serbia this year, or 2016. I was trying to delete like a 16 gigabyte partition I had that had an old version of FreeBSD when UEFI was first coming in that I used to test on my laptop to make sure the UEFI stuff worked. And I was trying to delete it. And I accidentally deleted partition number 2 or 3 from ADA0 instead of ADA1. So what I had done there is actually erase the Windows partition, which was important because I had an interview scheduled the next day to interview someone for this podcast. And that required the Windows partition and software to be working.
Sure.
So I tried just recreating the partition, but that wasn't quite right. Eventually, I SSH'd my home server, got a backup disk image, and got the partition table out of it to get the right offsets to actually going back to our first question, to recreate the partition because I knew the data was still there. I just had to line the partition up right.
I remember when that happened. Wasn't that at a you said that was at a hotel?
Yes, this
or
is at the
something?
hotel
Yeah.
for EuroBSDCon in Serbia.
A very poor time to have a partition go.
Yes, because, the interview was at noon the next day, and this was like 2 o'clock in the morning. All of us sitting around. Everybody else was drinking. I wasn't drinking. I don't drink. But, I typed ADA0 instead of ADA1 and deleted totally the wrong thing.
Alcohol and partition tables don't mix. Is that what you're trying to say?
I didn't have any alcohol, but yes.
Yeah.
My point was, safeguards are important, but they only protect you if you actually heed them.
Right. Okay. Well, thanks. That was actually Sean Webb over at Hard BSD sent that in. So thanks, Sean, for sending that in. We appreciate it. And then next up, we have Andrew, who says, hi, Alan and Chris. A few weeks ago, not sure if it was on TechSnap or BSD Now, Alan made a comment about bootloaders along the lines of a computer needs an operating system to do anything, but it needs to load the operating system from disk, and likened it to a man in a hole lifting himself out by his bootstraps. It made me curious about how a bootloader works. Once the bootloader is loaded up, how does Grub or the BSD loader, etc., load the kernel off the disk? And even more perplexing is how it works with ZFS, where the kernel could be in 10 different places across the disk.
Yeah,
you actually could speak a lot to that because you wrote a lot of the BSD bootloader. But on the Grub side, so Grub is almost like a little mini OS in and of itself, and it has drivers for things like ZFS, for example, or Jelly or whatever. And then it's able to, in turn, look for the magic location for the kernel, so boot kernel, or wherever it happens to be, whatever disk it's pulling it from. And then based on that, it'll load the kernel into memory, load modules into memory, and then start execution. But for a look at the BSD side, I'm curious actually how you figure out which boot environment to load the kernel off of. Is it just with the bootfs equals on?
So this is interesting. So the first part is the bootstrap code, which is actually boot 2. Yeah. So all this is described in a little bit of detail in my paper from Asia BSDCon, because as background, had to walk through that process to show how I added support for encryption into the middle of that. But some of that I actually stole from I think it was the architecture handbook for FreeBSD, which actually the very first chapter is how a computer boots, is bootstrapping the kernel initialization. So there's actually a book. It's not the FreeBSD handbook. It's one of the other books, the architecture handbook. But it describes this process in a bit more detail than I do. But basically, the BIOS reads the very first 512 bytes of the disk, and that will have either an MBR, if it's MBR formatted, or a protective MBR if it's GPT. And basically, there's 446 bytes of code there that describe how to start the operating system. In FreeBSD's case, that code literally consists of how to read a bigger bootloader and run that. So in the case of MBR, what that does is find the partition that's marked active and read the volume boot record, which is the first 512 bytes of the partition, and boot off that.
Sure.
And then for UFS, that VBR, or volume boot record, contains enough code to read the first 15.5 kilobytes of the UFS partition, the one marked A, which is the boot one. So UFS purposely leaves the first 16 kilobytes of the partition blank, leaving 512 bytes for the VBR and 15.5K for the UFS bootstrap code, which is basically a small implementation of UFS that has enough to be able to say, find me the inode number for the file /boot/kernel/kernel or /boot/loader even. And once I got the inode number, I can go through the block map and find which sectors, read those into memory, and then run that code. And that's how it starts. So for ZFS in GPT, the PMBR has, again, it's 446 bytes of assembly. It looks through, it can read the GPT partition table and finds the one that has the type FreeBSD-boot. Then it copies the first 536 kilobytes or the maximum, the size of the partition, whichever is smaller, into memory and runs that. So that's boot 0. Then boot 1 is the first 512 bytes of that, which then reads boot 2, which is actually the first bit of stuff that's actually written in C instead of assembly. And this is will be GPT boot or GPT ZFS boot, right? So when you've done gpart boot code to install the boot code, GPT ZFS boot is the boot 2 file. That is a binary, a statically compiled executable that contains a very basic read-only implementation of ZFS. So it's got the code that loops through all of the hard drives that the BIOS exposes, looking for the GPT partition table to find FreeBSD-ZFS partitions. And when it finds them, it tastes the raw device and any partition labeled ZFS until it finds a zpool, and then it tries to basically do zpool import. From the metadata of the zpool, it gets a list of all the other disks, and basically it tries to find all the disks. And it actually has compiled down into that little, used to be 43 kilobytes until I added encryption and support for another hashing algorithm and a couple other stuff. Now it's about 100 kilobytes. And that code has a basic implementation of ZFS that can read the kernel and actually follow the blocks and use all the different disks. So even though the kernel's spread all over the place, it can find the individual blocks, like the copy them all together into memory and into something that you can actually execute. Although actually, it doesn't usually do the kernel. That code just finds the loader, loads that into a certain place in memory, and tells the CPU to start executing that. Then the loader is a bigger binary. It's like 400 kilobytes. It has a slightly beefy... actually, I think it shares the same implementation of ZFS. But for UFS, I think it actually has a slightly beefier implementation. And then that actually reads the kernel and the modules, has the forth to draw the menu, all that stuff, and then it boots. But yeah, so I've added links in the show notes under Andrew's question for my paper from Asia BSDCon that describes in some detail how that process works and where I changed it to add the encryption support, and a link to the FreeBSD architecture handbook, the first chapter of which is bootstrapping the kernel, which covers the BIOS, the master boot record, boot 1, BTX server, boot 2, loader, kernel initialization, and how all that works. But it also has documentation on how locking works, how objects in the kernel work, how jails work, the sysinit framework, trusted BSD, virtual memory, how symmetric multiprocessing works, how to write device drivers for ISA, PCI, SCSI, USB, NuBus, how the sound system works, all this stuff.
Yeah, it's pretty exhaustive.
And includes like 32 diagrams.
Nice. Okay, well, you learned everything about bootloaders today. We had a little lesson there. That's great. Thanks, Alan. So lastly, we have somebody writes in. Let me see the name here. Yeah, Brian writes in. He said, Alan, first of all, sorry for misspelling your name. As a guy with a weirdly spelled name, Brian, I don't normally pay more attention to that. He said, but that said, my FreeNAS is reporting an odd error, and it's odd to me because of my newness to ZFS. I'm hoping you can help me out. It seems like I have data corruption in 2 files that I can't actually find on disk. And he gives us the output from zpool status. Any thoughts?
So in particular, we see the 2 files that are having errors are actually files that have since been deleted. So we
Yeah,
see
they're-
the blocks that are having the errors are actually in the file system tank0/.system/cores. This suggests they're kernel crash dumps. So explain
Sure.
maybe how they got corrupted. Hard to say. But we see then at and then a snapshot name. So
Yep.
these are files that only exist in the snapshot and have been deleted since then. So they don't even have file names anymore because they're just bits of data that are being held on to by the snapshot.
Sure.
So
I think he's good in this
yeah,
case.
so he
These
didn't actually lose anything, but ZFS has found these errors. It's slightly interesting that you see these checksum errors across everything. So he said he did a zpool scrub and it still showed up. I think in this case, if you actually delete that snapshot, then those files will go away and
yeah.
you can zpool using zpool clear will reset all those counters to 0, which can be useful to let you notice if they ever go to not 0 again. Whereas you might not notice it changing from 3 to 4, but you will notice if it's ever not 0 again.
Yeah. If it's not 0, then hey, something's not right here.
So yeah, you can, if you want, you can delete that snapshot, then do zpool clear, and then do a scrub, and hopefully you have no other checksum errors and everything's fine.
Very
Not
nice,
entirely
very
sure what
nice.
happened there, but luckily there was no data.
Luckily, it's in something. Yeah, it's not critical. All right. Well, thank you, Brian. We appreciate it. And that actually wraps up the show for us this week, folks. So, of course, we got to remind you, feedback@bsdnow.tv. That's the address you want to send everything to because that's what we monitor. So if you send something there, me, Alan, and JT will all see that. But send, of course, questions, comments. If you have any show ideas or topics, if there's any stories you find floating around the net, please do send those in because we can't read every GitHub site and every blog post and every news site and every comment.
If you figure out how to do something, like, say, set up some beehives in order to do a network test lab, do write it down and send it to us because it's other people will find that very useful.
Yeah, and if you do it on your Twitter account, then you'll get some new followers. People probably going like, oh, I should watch this guy. So anyway, good stuff. Please send it in to feedback@bsdnow.tv, and we'll use that to get, of course, included into future episodes. But, of course, we thank you all for being here this week and look forward to speaking to you again same time next week.
Oh, and just a reminder, TechSnap, the podcast I used to host, is actually now has new hosts, including Dan Langill of BSD Can fame and FreeBSD Diary.
Oh, yeah.
So do check that out at techsnap.tv. That's going to be live on Tuesdays now instead of Thursdays. So while you're waiting for the next episode of BSD Now each week, you could actually be entertained by TechSnap.
Great. Well, yeah, definitely check that out. We wish Dan all the luck with his new show there. That's great.